No, not now. Report. Brian, Brian. Dunbar, Dunbar. NASA. I am not. Thank you.
Okay, stream is running. Again. What? Okay, stream is running. What? Stream is running. I don't get it. Why? Well, Andrew can't tell me what's wrong. We had it once. But he can't get me back to. Am I getting this through the? No, it's not. Okay, Andrew, I could really use your help. I give up. I don't know what to do. I get it set up and it never streams. And God bless Andrew for all that he has done, but he can't explain it to me.
listen-only mode until the question and answer session of today's conference. At that time, you may press star 1 on your phone to ask a question. This conference is also being recorded. If you have any objections, please disconnect your line at this time. I would now like to turn the conference over to Gray Hautaloma. Thank you. You may begin.
Thank you. Hello, I'm Gray Hautaloma with the NASA Headquarters Office of Communications. Today we're here to discuss another step forward in the Artemis program's work to land the first woman and the next man on the moon in 2024 with the Artemis 3 mission and establish a sustainable human presence on the lunar surface. Science will be a big part of humanity's return to the moon, and today we're here to find out more about the report of the Artemis 3 Science Definition Team. That report deepens the collaboration between NASA's Science and Human Exploration and Operations Mission Directorates as we work toward shared goals at the moon. If you haven't had a chance to see the report, it is posted at nasa.gov/reports, as well as a news release about it that is also at nasa.gov. With us today are Tom Serbuchan, Associate Administrator of NASA's Science Mission Directorate, Ken Bowersox, Deputy Associate Administrator of NASA's Human Exploration and Operations Mission Directorate, Renee Weber, Chief Scientist at NASA's Marshall Space Flight Center and Science Definition Team Lead, Sarah Noble, Lunar Program Scientist at NASA's Science Mission Directorate, and Jacob Bleacher, Chief Exploration Scientist in NASA's Human Exploration and Operations Mission Directorate. I'm going to turn it over to Thomas right now to kick it off.
Well, thanks, Gray. First, I want to thank all the members of the Artemis 3 Science Definition Team and the community representatives and ex officio members. You all worked so hard to define the report NASA released today, the compelling science objectives for NASA's Artemis 3 mission. The moon is our gateway to the solar system, and it holds immense scientific potential to answer fundamental questions about planetary science, and that have continued to grow over the past decades. As a scientist, I'm excited for humans to get back to the lunar surface. I know the entire community is, and the value of lunar exploration has been articulated by many stakeholders. Just next year, we're on the cusp of the first commercial lunar payload services deliveries of science and technology payloads, and that initiative figures into this report. Artemis 3 will enable the science community to make significant progress on many of the highest priority science goals at the moon, and the investigations prioritized by the Artemis 3 Science Definition Team are also helping NASA understand the risks and potential resources of the lunar South Pole to prepare for the sustained human presence on the moon. Our colleagues can get into more detail about what we want to do at the moon with Artemis 3, both from a human and scientific perspective. I know we can't achieve everything at once, but we will build on what we have achieved in each mission towards the big goals and big questions about the formation of our solar system and the very makeup and history of our nearest neighbor in the cosmos. The team considered the lunar community's highest priorities of lunar science based on several previous documents, reports, and missions, and also considered input from the broader science community through the solicitation of public white papers on specific disciplines. Our team found activities related to field geology, sample collection and return, and deployed experiments are all part of the necessary mix of work to advance the science program at the moon that achieves our highest priorities. Robotic and human exploration go hand in hand, and NASA's science and human exploration teams are working together as never before to ensure that we leverage each other's strengths even before Artemis 3 lands on the lunar surface. What NASA is already doing in science will help prepare for the Artemis 3 landing and maximize the science value of having humans on the lunar surface. And this report helps ensure that we are doing so in a strategic and collaborative fashion. Artemis 3 is a beginning, which we celebrate here today. And I would like to turn it over to Ken Bowersox, who has flown in space for over 200 days, including his 2 Hubble repair missions that continue to pay dividends for science till today. Ken is now the Deputy of Human Exploration Operation Missions Director. Sox, go ahead.
Hey, thanks, Thomas. You know, when I joined NASA back in 1987, I had hoped that by now I would have gotten to actually go back to the moon. But of course, I didn't get to do that as an astronaut, but I'm really fortunate to get to participate with you and the rest of the team here as we plan for future missions where astronauts will make it to the moon. And so this is a big day for me to see one more step complete as we move towards putting humans on the moon again. We've had a lot of other positive steps this year. We've got the core stage for Artemis 1 going through Green Run down at the Stennis Space Center. Today, they're working to tank the vehicle for the first time. We've put the Orion vehicle for Artemis 1 through its thermal vacuum test, and it's sitting down at the Cape just about ready to go on that mission. We've selected 3 contractor teams for the Human Landing System base period. And moving into next year, we'll down select to the Human Landing System providers who will actually build the vehicle for the Artemis 3 mission. We'll fly Artemis 1 next year, and we'll be continuing assembly of the elements for the Artemis 2 and Artemis 3 mission. So a lot of work this year and a lot of great work ahead. The Science Definition Team Report, of course, is going to be very important as we advance our mission planning for Artemis 3. We still need to select the site where we're going to land. We need to plan the daily activities for the crew. And that detail will happen over the next few years as we get closer and closer to the mission. And this report, setting the priorities for the science to be performed, will be incredibly important as we try to maximize the value of every minute that our crews spend out there at the moon. And so now I'd like to pass the mic over to Renee Weber, one of the co-chairs of the Science Definition Team. Renee?
Great, thanks, Ken. Fortunately, this Science Definition Team is not the first to have thought about doing science on the lunar surface. In fact, the lunar community has been planning exploration strategies ever since the Apollo era. So to maximize input from the entire science community, our team solicited public white papers, like Thomas mentioned, but we also pulled from many existing strategic documents to populate the science goals and investigations that you can read about in the report. And that includes the 2013 Planetary Decadal Survey. There's a full list of all of the guiding documents that we used in Section 3 of the report. Artemis 3 is going to provide a unique opportunity to advance science. The moon serves as a cornerstone within our solar system for a breadth of high-priority science questions. The team organized our discussion in this activity around the 7 science objectives that are defined in the Artemis Science Plan. And I'm just going to go through those really briefly, but please note that they are available in the report. The first is understanding planetary processes, which includes how planets form and evolve and what processes shape their surfaces. The second is understanding the character and origin of lunar polar volatiles, especially the presence and abundance of water ice, which we know is incredibly important for sustained human exploration. The third is interpreting the impact history of the Earth-Moon system, looking at impact craters and the impact cratering process. The fourth is revealing the record of the ancient sun and our astronomical environment, which includes space weather, which is also very important for human exploration. The fifth is observing the universe and the local space environment from a unique location, which basically means using the moon as a platform to make observations of other places. The sixth is conducting experimental science in the lunar environment, which captures the biological and physical sciences. And the seventh is investigating and mitigating exploration risks. So again, relying on our guiding documents, we populated all of these objectives with the highest priority investigations that we think can most feasibly be executed during the Artemis 3 surface mission. And that maximizes the science that we can do within that framework. The report represents a comprehensive science plan for Artemis 3 that requires a balance of investigations that encompass lunar sample return, field science on the surface, and deployed instruments on the surface. So at this point, I would like to turn it over to Jake Bleacher, who will discuss how these science objectives are incorporated into human exploration architectures.
Thank you, Renee. I joined NASA in 2006, in part to help land astronauts on the moon. Shortly after that, we launched a lunar reconnaissance orbiter, and we've been collecting data with that orbiter to help us determine where to go and what to do on the lunar surface. And so it's really exciting for me to be involved in this effort now to land astronauts at the south pole of the moon, which is a really interesting place where no one has ever been before. And not only land, but come home with new knowledge and data to advance our understanding of the moon and our place in the solar system. It's also exciting to support our science colleagues in the announcement of this report, especially on the 48th anniversary of the launch of Apollo 17. As was shown by our Apollo predecessors, it's in our nature as humans to explore. Just as for all of our exploration predecessors before us, science and exploration go hand in hand on this adventure, as Thomas already mentioned. Science not only asks us the questions that drive our exploration, scientific study of the moon has and will give us the critical knowledge we need to not only survive, but thrive in the harsh lunar environment. As we learn more, we'll know how to ask better questions, form more detailed hypotheses. And around this knowledge, we'll continue to evolve our exploration architecture to help find those answers. This Artemis 3 Science Definition Team report serves as a critical contribution to our Artemis planning as we move forward. We will work together with our SMD colleagues using this information to help understand what our astronauts are actually going to do on the surface of the moon. It will help us answer questions such as what type of data will they be acquiring and how are they going to collect it. This understanding will help us develop a collaborative plan to use the Artemis hardware to conduct this valuable research. For instance, what should the Artemis equipment be capable of? Perhaps even more important, how do we ensure that our approach will avoid as much as possible interfering with the science that we hope to accomplish? Additionally, these results will help us understand where we need to go. It will influence how we develop detailed mission and EVA plans, as well as develop training for our support teams and the astronauts who will actually be walking around on the surface of the moon. To best prepare them for when it's their time up there, it's our time down here to do this work that will ensure the success of Artemis mission. Gaining these insights in collaboration with SMD will help to ensure that we're prepared and can maximize the science during this exciting lunar landing. So on behalf of human exploration, I want to thank our SMD colleagues for organizing this effort, the entire science definition team, and the community consultants, as well as the many scientists that contributed white papers for the report. By building upon the past efforts and documents that Renee mentioned to help characterize the lunar science, and by bringing together input from the community for current thoughts on lunar research, we best ensure that when we land the first woman and next man on the moon, we'll be conducting the most valuable science possible. And with that, I'd like to hand the conversation over to Lunar Program Scientist Sarah Noble from the Science Mission Directorate.
Thanks, Jake. So I know that reports can sometimes be pretty dry reading, but I hope that it comes through in this report just how excited the lunar science community is about the opportunities enabled by the Artemis program. With this report articulating their highest priorities, we're ready to take full advantage of those opportunities. The Lunar Reconnaissance Orbiter and the other orbiting missions we have sent to the moon over the last couple of decades have really evolved our understanding of the moon. We've answered some questions, and we've created some new ones. And now we're at a point where the next big leap in understanding is going to require us to get back down to the surface. And that's exactly what we're doing. Robotically, through the CLIPS program, the Commercial Lunar Payload Services programs that Thomas spoke about earlier, and with humans through Artemis. Artemis will allow humans to not only bring home new samples from a new location far away from any of the Apollo sites, but also to bring home the right samples, collected with well-trained eyes, well-documented, collected in complex ways that will allow us to address these high-priority questions we've been asking and refining for decades. It will also allow us to deploy complex instruments, new tools to understand the moon's internal structure and the lunar environment. Like Apollo, I'm sure that the samples and the data collected by Artemis will be studied and will continue to provide dividends for decades to come. The results will allow us to advance not only our understanding of the moon, but also, as Renee said, the moon is our cornerstone, and we can use it to help us understand how fundamental processes work across the solar system and beyond. This report is a really important step towards that achievement, and I want to sincerely thank Renee and the entire team for all of their hard work. And with that, I'll turn it back over to Gray.
Okay, thanks everyone. Just as a reminder, press *1 to get in the queue for a question. We'll get to as many as possible, but please do limit yourself to one and direct it to one of our panelists if you can. Operator, we're ready for the first question.
Our first question comes from Elizabeth Howell. Ms. Howell, your line is now open.
Thank you. This one will be for Sarah, I believe. You had already alluded to the fact that Artemis will allow the humans to bring samples from new locations and using new complex sorts of operations. Can you really elucidate how an astronaut could be collecting samples and doing scientific investigations in a way that, say, a rover or some other sort of robotic landing system would not be able to do?
Sure, right. So, we have opposable thumbs. It makes it a lot easier to do more complicated things like drilling cores and digging trenches. It also allows us to, do things much faster. Our human brains react a lot faster than our communication systems with rovers. And so we train the astronauts. They're basically geologists by the time they're done with their training. And so they can use their geologic brains to pick out the right samples in a way that it's much more difficult to do robotically.
Okay, thanks. Next question, please.
Our next question is going to come from Stephen Clark. Mr. Clark, your line is now open.
Hi, thank you. Stephen Clark from Spaceflight Now. I think my questions are for Ken Bowersox. First of all, can you talk about the process that NASA is looking at for selecting a landing site somewhere in the South Pole region? What factors go into that, and what limitations are the human landing system? What limitations will the human landing system have in terms of slope or just hazards, things like that? And also, Ken, can you update me on the issue with the Orion Power Distribution Unit? There's some reports that it could take months up to a year to repair. Is that true? And just some background on the repair option and what the actual issue was. Thanks.
Okay, well, I'll start with the power distribution unit. Whenever we have a technical issue, and we have technical issues all the time with all of our programs as we get closer to launching them, you'll get a first report, and the first report will show all the worst case possibilities. And, the worst case for this one, as you mentioned, could be that it takes us a while to fix it. On the best case side, we may find that it's something we can live with. I'm not going to make that decision right now as we're talking, right? We've got a big team of folks that's looking at all the details and trying to decide just what makes the most sense for us. But as we look at it, we really don't think that it's going to be a big impact on the final schedule for the Artemis 1 flight. But like I said, we're going to look at all the details and make sure that we've considered all the data before we make a final call on that. As far as the missions themselves, the human landing systems, will have specific capabilities dependent on the individual system. Some of that will come out in the actual selections. Again, we're in blackout for those selections, so I don't want to go into a lot of details. But we'll be looking at all their capabilities as we try to pick which system will make the Artemis 3 mission. And what was your first question? Want to repeat that for me again?
Sure, Sox. The first question was the selection process for the landing site. When does that process begin, and what will it look like?
Yeah, and we are working on that selection process. I don't want to reveal any of the details because we're thinking about trying something a little bit different this time, and I'm just going to stop right there. But we have ideas, and we're going to be trying to consult as wide a group of people as we can.
Okay, thank you. Next question, please.
Our next question comes from Jeff Faust. Mr. Faust, your line is now open.
Great, thank you. A question on collecting samples. I know the report's got some findings about how to collect samples, such as cryogenic samples, vacuum sealing, and so on. The question is about how many samples you can collect, and is what's being the goals being set forth for the Artemis 3 mission and the HLS guidelines in terms of how many samples you can collect sufficient to meet scientific goals? Would you like to collect more? Do you need to collect more in order to achieve some of the scientific goals you've set out here in this report? Thanks.
Hi, this is Renee Weber. I think I can answer this for you. So in the report, we do outline some of the capabilities of the Artemis HLS system, the human landing system, which does dictate down mass and up mass capability of the lander. So of course, anything that we bring down to the surface and anything that we return back to Earth has to fit within those mass allocations. And so we do have a recommended table of samples to address exactly your question. Given this amount of mass, what types and how many samples should we bring back to address our highest priority science questions? And to a certain extent, those numbers are flexible because those requirements are actually not 100% confirmed yet, again, because of the selections being not made yet and they're in the blackout. So the team tried to take that into account to specify, at the barest minimum, here's what we should bring back. If we have a little bit more, we can accommodate more. And the sort of breakdown and categorization of those samples changes based on those capabilities.
Okay, thank you. We're ready for the next question.
Our next question comes from Keith Cowan. Mr. Cowan, your line is open.
Hi, Keith Cowan from NASA Watch. The science part of this report looks great, but I'm confused about the human part. At this point, and again, I don't know who wants to answer my question, probably have to defer to Thomas on this. At this point, prior to the Apollo landings, as early as 1965, the Apollo program had astronauts that were in the field training for lunar geology, and they were flying simulators based on an established mission architecture. At the same point, prior to the first landing of the Artemis program, only part of this is in place. When will you pick the crews and start training in simulators and have crews out in the field? And how are you going to do this given that the mission architecture is still several years away from even being established? Can you really pull this off so as to be ready to go in, 4 years exactly from today? It seems a bit compressed.
I was actually suggesting that Sachs take that as opposed to me. Go ahead, Sachs.
Yeah, thanks, Thomas. Hey, hi, Keith. What I would say is I think you're going to see a lot of progress in that area in the next year. One of the big things that's going to help us there is when we down select to the actual commercial partners that'll provide our landers. And I think you'll see a lot of progress. We've been talking a lot about what we want to do for training platforms for the landing, things like that. And I expect you'll see that progress in the next few months to a year. And yes, it is aggressive.
And when are you going to pick your astronauts? Are you just going to wait till the last minute? These guys need to be trained.
Well, we've already started some of the training, right? Every ASCAN class gets some geology training, and we have people participating in desert rats and those kind of programs, and surface analogs. But the specific training, the flight-specific training for this mission, for the Artemis 3 mission, I'd expect that'll probably start about a year and a half, 2 years prior to the mission. So we still have a little bit of time before we get there.
Okay, thank you. Next question.
Our next question is going to come from Randy Segal. Mr. Segal, your line is now open.
Good afternoon. I have a very simple question. Are you going to be, this is probably for Sachs, I would imagine. We still have 3 living moonwalkers, Dave Scott, Charlie Duke, and Harrison Jack Schmidt. Will you be contacting them? Have you contacted them concerning what they did on the surface of the moon? And also, will you be having a special new spacesuit for this particular mission?
Well, I'll take the second question first. We are developing a new suit for the Artemis missions. We call it the XEMU. That's in development now, and we expect to do some testing on space station here in a few years, and then use it on the surface of the moon. As far as advice from previous spacewalkers, I mean, we've been polling them since they walked on the moon, trying to get their thoughts recorded, so we can have those when we finally do put humans on the surface of the moon again. And I'm sure we'll be consulting them as we get closer, just asking their opinions on things. Well, there was a really great report out a while back where we recorded a lot of the observations from those folks who were on the early missions, and that's an invaluable reference to us as we plan future missions.
With all of this, you're going to have a new president coming in next year. And there's a lot of talk as to whether we go in 24 or 28. What are your thoughts?
Honestly, I've been thinking about this for a long time, right? I was interested back in the 60s when we were sending the first cruise to the moon, and joined NASA hoping to go to the moon. So I'm basically an impatient person. I'd like to go tomorrow if it was up to me. But I've learned that it's not very productive to argue over which date, but instead to make continuous progress. And that's what we're focused on every day here in HEO, is just trying every day to make sure we're making steps towards getting humans on the surface of the moon. And it's exciting to me to see the progress that we've got politically. We've got bipartisan support for moving out towards the moon and to Mars. We've got some money in the budget. It may not be as much as we asked for, but we've got money in proposed budgets, and that's going to help us make progress step by step.
Thank you very much.
Renee, did you want to quickly touch base on some of the Apollo era people that have participated and or given us information?
Yeah, I would love to add that our remaining moonwalkers are very much engaged in the science community. Jack Schmidt, in particular, is active on many teams, including the teams looking at the next generation Apollo samples, plugging into our lunar surface science workshops that have been ongoing over the past few months, participating through the lunar science community, active on email lists, and we very much value their unparalleled expertise and very much rely on it as part of our planning.
I'm glad we're using all the resources.
Yeah, and I'd like to add to Renee's comments as well. Keith asked earlier about the training that the astronauts are going to be undertaking, and Ken mentioned that they have gone through some of that training in their early candidacy years when they're first selected. And in fact, the Apollo folks have contributed to that training as well. So they have had a good bit of direct input into not only how we train them up, but what we want to train them to be able to do, as well as what those science objectives will look like as we get closer to having the astronauts on the surface.
Thank you so much.
Okay, next question. Thank you.
Our next question is going to come from Christina Anderson. Ms. Anderson, your line is now open.
Thank you for taking my question. I'm wondering about the power source. Can you talk a little bit more about what you're looking at? What are the parameters being evaluated? How long are you looking? You're saying it's a long-term, you're hoping for a long-term power source. What does that mean in terms of years? And will that, obviously, I guess that will have an impact on the selection of the isotope. If you're using the RTG, I'm just curious about how all that is coming together. Thank you.
So I can comment at least on the utility of such a power source to the actual science investigation that the report recommends. We do name it, or not it specifically, but a long-lived power and communication system that can enable sustained observations from the surface of the moon. We do recommend that as an enabling capability in the report, recognizing that there is a desire to deploy instruments on the moon similar to Apollo that can gather and return data after the astronauts leave the surface. So that is something that we have looked at, and I may have to ask some of my colleagues here to comment on the actual plans for developing those things.
Does anybody else have any further comment? Go ahead.
Well, surface power is one of the major thrusts being undertaken by our Science Technology Mission Directorate. That will affect a lot of our later missions, right? I would anticipate that we'll be looking at battery power and solar power for Artemis 3 because it's just, too early to get the type of power systems we want built to supply that mission. But later on, we'll have more sustainable sources of power.
And I just want to say from my end that, of course, we have a number of technologies available now that we can use, that we are using on Mars, whether it's RTGs or just radioactive heaters, if you want. That those are technologies we have maintained and that are going to be considered. I think the most important part that I just really want to talk about again on this report is that what we're trying to do with this, and that's why I'm so excited about this, and thanks again to the whole team, is we want to be sure that we actually prioritize the science now so these decisions can be made in a way that are consistent with our mission profiles and overall, right? If you want the problem is almost we have too many options, right? We need to kind of narrow down the options, both from the maturity side, just like Ken talked about, but also from the science utilization. Where are the power needs? How much will they be? And then there's technical solutions that we have, a number of them available, and some of them as we go into the future that we want to develop, just like Ken said. Thank you.
Okay, just want to remind everybody that you can ask a question by pressing *1. So get in the queue if you do have something, and we would like to focus on the actual report itself, since a lot of our team members here are about the Science Mission Directorate and the actual work on the report. We're ready for our next question.
Next question comes from Zach Hall. Mr. Hall, your line is now open.
Hey, this is Zach from SpaceExplorer.com. One quick question is I love the cat in the background. I was curious what the cat's name is if someone has had to work remotely this year. And then next, more seriously, is I like in the report the 7 science objectives being laid out. Can anyone talk kind of at large about what they're most excited about of these, and what kind of insights do you think we'll have after this mission based on what's being prioritized?
So, believe it or not, the cat's name is Luna, and she's very excited about the report. Renee, do you want to take what you're most excited about?
Well, I'm yes and no. I would like to answer that question. My own personal background is in geophysics, and those are the types of investigations that, of course, excite me. I did my PhD research looking at Apollo seismic data, which at the time was one of the only extraterrestrial seismic data sets available. Of course, we now also have seismic data from Mars, thanks to the InSight mission. But coming back to the moon, I would like to say that I think all of the science that we have outlined in the report is extremely valuable and extremely exciting. We haven't been back since Apollo, and I like to think of it not as going back, but as going forward, because there's so much left to learn. I want to reiterate one more time the fact that the moon is the cornerstone for understanding terrestrial planets, not only in our own solar system and our own planet, Earth, but also looking out into other solar systems and exoplanets across the universe. So we really have this amazing opportunity to continue Apollo's legacy and to dive deeper into questions that we won't have an opportunity to answer anywhere else. So overall, I'm very excited to have been a part of this, to have produced this product that we can allow others to build from, and future Artemis missions to build from.
And I can jump in here too and say, working on the human exploration side of this, what's really exciting to me looking at these results is trying to help understand how we will evolve this architecture, make these technological decisions to help make sure we can address that high priority science. So as Thomas noted earlier, understanding and prioritizing the science as we move forward is really the basis to help us sculpt what the architecture looks like. And several of these objectives present us with technological challenges. I mean, what's really exciting about what we do is, the simple goal of landing astronauts on the moon and bringing them home safely with new science information. I mean, that's a huge goal, and we have to create new technological capabilities in order to do that. And so when I look at these science objectives, bringing back cold materials so that we can understand volatiles, or trying to preserve delicate features of what we see in the regolith on the moon, or, keep rocks from being contaminated as we bring them back so that we can do that science. These are all wonderful technological challenges that we can work on together collaboratively between our directorates to make sure that we can really maximize that science. So to me, I kind of, pick through these results and look for those really exciting challenges that we'll have, both for Artemis 3, but also looking down the road as we set the stage for the rest of the Artemis missions.
I just wanted to just quickly jump in here. If somebody asked me what's the most exciting part for you on this one, of course I would start where Renee is, but then I probably would end and basically say, hey, what's really exciting to me is that sample return. Just absolutely can't wait for it, especially a sample return that as we go forward, will be affected by the best way of getting samples, which is a person who actually sees the environment after landing and chooses the most valuable samples based on the training that they've gotten, both in the astronaut training, but so often in the previous training. I think the one thing that I wanted to also mention is just how far-ranging these kind of science results have really been. It was kind of funny as we prepared for this, but perhaps I want to have, Sarah and Renee and others chime in, but we realized how so many of us have been affected by the Apollo samples in a direct fashion. I pointed out, and some people have heard that I did my PhD in a group that was basically started because of the Apollo samples, right? And with, frankly, in a lab or next to a lab that was built to analyze specific topics from Apollo samples, both the rock samples, but also the solar wind samples. And it's just, for me, I think what we often miss is just kind of the far-reaching consequences these things have, not just on the science side, which is, of course, why we're here for, but also on the talent side, the capability side, and the whole community. And I just wanted to stress that also. I don't know whether Sarah or Renee or Jake or anybody, Sox may have something to contribute to this one too, of course, but I'm really interested in, just kind of that broad consequence of this kind of science.
Sure, Thomas. Yeah. I also, did my thesis on looking at Apollo samples. Actually, 30 some years after the Apollo mission, my thesis and many other folks have done their thesis even recently. We right now are in the process of just opening up some new samples from Apollo that hadn't been open for almost 50 years. These samples, the thing about samples, the science community always calls them the gift that keeps on giving. And as we, develop new ideas about the moon, as we develop better technology, these samples will continue to pay dividends, as I said, for decades and decades to come. And that's what I'm most excited about.
Yeah, and Ken here, I'm excited too. Some people are surprised when pilots get excited about the science, but as an aerospace engineer, I keep thinking about turning rocks or lunar polar volatiles into rocket fuel someday. So that really kind of thrills me. But I'm also really interested in hearing about what we learn from the geologic samples we bring back about the history of the Earth and Moon and our solar system. That always fascinates me.
Okay, thank you, everybody. Next question.
Our next question comes from Christina Anderson. Ms. Anderson, your line is now open.
Thank you. This is a follow-up to my earlier question, and it ties to finding 7.1-1 on the long-term power source. So I'm wondering, what I'm trying to get a grasp of is are we thinking about a fixed power source that will stay there on the moon and not only serve for the Artemis 3 mission, but maybe beyond that? Power seems to be central to all of the science, and so I'm just trying to get a better idea of how to think about the power question. Thank you.
Hey, Jake, do you want to talk about that? Do you want to talk about surface fission power and when we might use it? You know, we show it on our swoosh charts.
Yeah, so those are the concepts that we currently have in development. We recognize that as we strive to have more sustained presence on the lunar surface, that obviously comes with an increase in needs on power. And so we'll be working on that. And as Ken said, we're looking at some of those options like fission power. But this early mission, this report is really focused on the Artemis 3 mission. And what we're expecting to have for Artemis 3 is powered on solar power and the batteries that we take along with us. And so what we're trying to do here is learn about this South Polar environment. As several of us have mentioned, this is a location that we've never been before. And one of the reasons that we are directed to go to the South Pole is because of that unique environment. It's a very unique environment from the perspective of lighting. And because of that lighting uniqueness, there are some other aspects such as access to volatiles that may be preserved here because of lack of light in some of the deep craters. And so these early missions, especially Artemis 3, and as Thomas mentioned earlier, we don't want to forget about the CLIPS missions. These are going to really be missions that help us understand that environment, and that scientific exploration of the environment is going to be critical to help us make decisions on how and what we bring to the surface to support that sustained presence. And as Ken mentioned, that the power sources that we could choose to bring to the surface, that will come over the next handful of years as we're striving to be in a more sustained presence. But right now, that initial mission, Artemis 3, for which this report is about, is depending on solar power.
Okay, thank you, Jake. Well, I think we have gotten to all the questions, so we're going to wrap up the call. If you want to hear this again, there will be a replay that will be available in about an hour. It will be up for a month. That number is 800-867-1924. Let me just repeat that. The number for the replay of the call is 800-867-1924. I want to thank everybody for coming today. Thomas or Ken, did you have any final thoughts?
Go ahead, Ken.
I just want to say once again that this is a big day. It's one more step towards getting humans on the moon again. And we have a lot of steps ahead of us, and I look forward to seeing those check off. And eventually we're going to get there. And Thomas, I'll pass to you.
Yeah, I just want to thank Ken and, of course, the whole EO team for the partnership on this. This is a huge opportunity for us to do science, and we couldn't be more excited to really take advantage of the opportunities that come from, the first woman and the next man on the surface of the moon with new questions, with new technologies here. I have to tell you, if I listen to a number, not only to the astronauts that were mentioned before, but also to a number of the scientists who are actually working with the astronauts and the entire Human Exploration Office, or what it was called then during the Apollo program. And so what we're really excited about is of course, the science results, but also learning how to kind of work together in this very different way. Of course, we've learned during the space station and several activities, and that will really benefit us. But what I'm really excited about is to create these new collaborations between scientists and human explorers, including astronauts that will go forward with this, and really enable this science that is outlined here. Renee and the entire team, I just really want to thank you again for the amazing work in this. And of course, this will be followed up by actions, because we need to, like Keith said and others, we need to get started and start moving the ball down the field, because we can't wait to actually get this science done. Great, back to you.
Okay, I want to thank our panelists and thank everyone for joining us, and this will conclude our event today. Thank you.
today's conference. Thank you for participating. You may disconnect at this time. Speakers, allow a moment of silence and stand by for post-conference.